Hello students, in this session we will discuss about the rules for finding oxidation numbers, right? Actually there is a slight difference between oxidation number and oxidation state. That is, if all the surrounding bonds are ionic bonds, means if a species is held only by ionic bonds, then in such a case we have to use the term oxidation number. Suppose NaCl, Na plus 1, Cl minus 1. Oxidation number of sodium is plus 1, oxidation number of chlorine is minus 1. That's the difference. In case if the surrounding bonds are either by gaining or by losing or by sharing of electrons, then in such a case we have to use the word oxidation state. Okay, often these both are considered as same. Okay, we need not get confused between these two. Right? Now let us go through the rules for finding oxidation number or oxidation states. The first rule is in elemental state or native state or free state, okay, in any one of these states oxidation number of elements is taken as 0. Suppose hydrogen, you consider hydrogen. What's the native state of hydrogen? H2 gas, right? In H2 form, H2 molecular form, each hydrogen possesses 0 oxidation number or oxidation state. H2 is a covalent molecule, right? So better we use the word oxidation state. Similarly, oxygen, what's the native state? O2. Oxidation state is 0. Similarly, fluorine F2, chlorine Cl2, bromine Br2, iodine I2, etc. In all these molecular forms, native states, their oxidation states are 0. Similarly, sulfur is available in the form S8. Phosphorus is available as P4. In these native states also, the corresponding elements possess 0 oxidation state. Is that clear? So what's the first point in this? In elemental state, oxidation state, if it is a covalent, if it is a bond formed by gaining or losing or sharing of electrons, we have to use the word oxidation state. Already we discussed that. In elemental state or native state or a free state, oxidation states of elements will be 0 always. Now let's come to the second point. Alkali metals, you know that the first group elements in the periodic table: lithium, sodium, potassium, rubidium, cesium and francium. Of course, francium is a radioactive element. That's why see it is specified with a different color, right? What are alkali metals? Group 1 elements in the periodic table, namely lithium, sodium, potassium, rubidium, cesium and francium. As francium is radioactive, usually their chemical properties are less pronounced, right? So these alkali metals, which are also called as 1A group elements because their valency is 1, which are also called as group 1 elements, in their combined state always shows plus 1 oxidation state, right, or oxidation number. Suppose lithium chloride, lithium plus 1, Cl minus 1, sodium bromide, Na plus 1, Br minus 1. So potassium iodide, K plus and I minus. See, in all their compounds, these elements possess plus 1 oxidation states only. See here I specified that. Alkali metals are 1A group elements or group 1 elements in their combined state always possess plus 1 oxidation state. What are alkali metals? Lithium, sodium, potassium, rubidium, cesium and francium. This is a radioactive element, its chemical properties are less pronounced. Is that clear? Next, when it comes to alkaline earth metals, means the second group elements, which is called as a 2A group or group 2 elements, they always shows plus 2 in combined state. Suppose magnesium oxide, MgO. Magnesium oxide, MgO. There magnesium possesses plus 2, oxygen possesses minus 2 oxidation number. Right. Similarly, beryllium oxide, BeO. Be plus 2, O power minus 2. Calcium chloride, Ca2 plus and 2 moles of Cl minus. Like this, in all their compounds, these alkaline earth metals possess plus 2 oxidation state. Is that clear? Next, when it comes to the common element hydrogen, usually in most of its compounds, hydrogen shows +1 oxidation state. Usually, in most of its compounds, hydrogen shows +1 oxidation state. Because means every atom will try to gain electron from hydrogen. That's why in most of the cases hydrogen loses one electron so that it will get +1 oxidation state. Understood? So what's the common oxidation state of hydrogen in its compounds? +1. But in its active metal hydrides, see MH, M is a metal. I specified that with a red color. There is a reason for that. M is a metal. Metal means which always loses electron. When metal loses electron, the next atom with which it is combined, that is hydrogen, has to gain that electron, right? So, in active metal hydrides where metal M is losing, where hydrogen has to gain. When hydrogen gains one electron, what's the charge it's going to get? Negative charge, right? That's why in active metal hydrides, hydrogen shows -1 oxidation state. Understood? You may get a doubt. Why can't it show -2, -3? No. Only as per the requirement to attain the nearest octet, they do nearest inert gas configuration, they do gain or lose electrons. Hydrogen's nearest inert gas is helium. Hydrogen's nearest inert gas is what? Helium, which has 1s2 configuration. So, to attain that 1s2 helium configuration, hydrogen needs just one more electron. That's why it gains one electron. Understood? So, once again, the common oxidation state of hydrogen is +1. But in its active metal hydrides, where metal M is losing electron and hydrogen is gaining electron, hydrogen shows -1. You have to remember all these rules. Okay, next. And another important point is, fluorine shows -1 always in its compounds. Fluorine shows only one oxidation state, that is -1 in its compounds, because that is the most electronegative element in the total periodic table. Which is more electronegative element? Fluorine. So it can attract electron from any other atom. Understood? It can attract how many electrons it need to get octet? Fluorine has 7 electrons in its outer shell. Do remember that point. Fluorine has how many electrons in the outermost shell? 7 electrons. It needs how many more electrons to get octet? Just one more. That's why it gains that required electron and thus shows -1 always in its compounds. Of course, in its native state F2, native state any element possesses 0 oxidation number. But other than the native state, in its combined state, means in its compounds, fluorine shows -1. Are you following? Next, when it comes to oxygen, this is most important point. When it comes to oxygen, oxygen is in 3 forms actually: oxides, peroxides and superoxides. Oxides means where oxygen will be with 2 units negative charge. Oxygen will be with 2 units negative charge. Oxygen atom can exist with 2 units negative charge. Means there is no free existence. It will be held with some electrostatic forces, these ions, right? Oxygen will be with 2 units negative charge. Then it is called an oxide or monoxide. In these monoxides, see, one single oxygen is bearing how many units of negative charges? 2 units. That's why oxygen shows -2 in its oxides or monoxides. Oxygen shows what oxidation state in its oxide form? -2. See, that same -2 I specified here. Means in monoxides, each oxygen shows -2. Is that point clear? This particular point is very, very important, and you need to apply these points in solving the examples for the competitive exams like JEE and NEET. Oxygen in its oxide or monoxide shows -2. Means each oxygen will get -2. When it comes to the peroxide, peroxide ion is in this way: O2 power -2. Means 2 oxygens are carrying 2 negative charges. 2 oxygen atoms are carrying 2 negative charges. Then for each oxygen, what's the charge? It's going to get -1. See, the same thing I specified. In peroxides, each oxygen shows -1. Each oxygen I am specifying. This is how a peroxide ion can be specified. Right? This is a ionic form of peroxide, O2 power -2, where each oxygen is bearing -1 value for oxidation state. In monoxide, each oxygen is -2. In peroxide, each oxygen is -1. We have to assign -1 for each oxygen. Understood? We are going to solve all these cases in a few examples. Next, in superoxides. Superoxide means like this, O2 power -1. Superoxide means what? O2 power -1. See here, how many oxygen atoms are there? 2 oxygen atoms are there. For 2 oxygen atoms, how many electrons were given? Just 1 electron. So 1 unit negative charge should be distributed between 2 oxygens. So each oxygen is getting half minus charge. It's the same I specified. So each oxygen shows -half in its superoxides. Each oxygen shows -half in its superoxide. For example, let us find oxidation number of oxygen in this molecule. In this formula, not molecule, formula. So we have to find the oxidation number of oxygen. We don't know, no, we are not aware of. Let it be X. Are you following? Let it be X. As we are not aware of oxidation state or oxidation number of oxygen, let it be X. Plus, sodium belongs to which group? Sodium belongs to which group? First group in the periodic table. First group elements always shows +1. Why +1? Because they are losing 1 electron, right? As they are losing 1 electron, +1 will be shown. So, first group elements always shows +1 oxidation number, as 2 sodiums are there, 2. And what's the charge this total species is bearing? Is it possessing any charge actually? Any plus charge on? Any minus charge? No, there is no charge. Means it's a neutral species, right? So, as it is a neutral species, sum of the oxidation states or oxidation numbers must be equal to the charge on the species. I am repeating, sum of the oxidation numbers of all atoms must be equal to net charge on the species. So, as there is no charge on the species, sum of these 2 charges should be equals to 0. Is this clear? Now, let us find the value of X. X corresponds to oxidation number of oxygen. So, +1 corresponds to that of sodium, because alkali metal always shows +1. +1 into 2 sodiums plus X corresponds to oxygen equal to 0. X equals to -2. What's the name of Na2O? Its name is sodium oxide or sodium monoxide. Both are same. We can use monoxide for an oxide. Understood? See, in this sodium oxide, oxygen possesses which oxidation number? -2. So this example is specified in the list of rules actually. Now let's come to the next case. Magnesium oxide. Magnesium oxide. So we need to find the value of oxygen now. So let it be X. Plus, magnesium belongs to which group? Magnesium belongs to which group? Second group in the periodic table, which is called as alkaline earth metal. All alkaline earth metals, second group elements in their combined form shows which oxidation number? +2. You remember that? So, +2 into only 1 magnesium is there. And as I said earlier, sum of the oxidation number of all elements must be equal to the net charge of the species. What's the net charge of the species? 0, as it is the neutral species 0. So, X equals to -2. Right? Now, let us find oxidation number of oxygen in Na2O2. In Na2O2. Of course, its name is sodium peroxide. Sir, how can you name it directly? We are unable to find it, what type of species it is. You know how to remove sodium? What's the charge that sodium comes out with? With what charge sodium comes out of species? It always possesses what charge? Sodium is a alkali metal, right? Alkali metal always shows +1. So each sodium comes out as Na+. 2 sodiums comes out as 2 moles of Na+. Plus, as 2 positive charges are out, O2 now will bear 2 units of negative charge. In the rules, the previous slide, I had specified this O2 power -2 as what's that? Peroxide ion. Oxide ion means what? Oxide ion means O power -2 I had given. O2 power -2 means peroxide. You have to remember all these things. See, by going through these rules several number of times, one can easily remember. You need not worry. Understood?
Sir, is it not necessary to represent +1 on the given compound?
On this?
No, on the above one, Na2O. Is it not necessary to represent +1 on top of O?
No need to, because it's not a charged species, it's a neutral species.
But still it has a +1 charge, right?
+1 is possessed by each sodium. 2 plus charges and 2 minus charges. Net is 0. Okay. Similarly, Na2O2, it is sodium peroxide. By solving certain number of examples, one can easily come to know. Similarly, see, before solving, let us take one more example. BaO2. BaO2 is oxide, dioxide or peroxide? It's a question for you. Oxide, dioxide or peroxide? It's very simple. Barium belongs to which group? That's why we should be very perfect in periodic table. Barium belongs to which group? Beryllium, magnesium, calcium, strontium, barium and radium. Alkaline earth metals, right? Second group elements always shows +2. Very good. So when barium is +2, obviously O2 possesses -2. So what is O2 power -2 called as? What is O2 power -2 called as? Peroxide ion. So this is what? Barium peroxide. What is this called as? Barium peroxide. So in this way, by looking at a particular substance, we should be in a position to infer whether it is a monoxide or peroxide or superoxide. We'll discuss again all these things, don't worry. So now it is a sodium peroxide in which each oxygen possesses what state? Let us find it, even though you may be aware of, but still we have to find. We don't know the oxidation number of oxygen, let it be X. How many oxygens are there? 2. So take 2X. X for each oxygen. So 2X for 2 oxygens. These 2 oxygens are totally bearing what charge? 2 units, negative charge. So what's the net charge on this species? -2 equals to -2. Right? So what's the value of each X? X is equals to -1. What's the point we learned in the rules? In peroxides, each oxygen possesses -1. See, in peroxide, each oxygen value, each X value is -1. For 2X, it is -2. Is this clear? Similarly, barium peroxide. Even for the formula also we can apply the same. Suppose we have to find the oxidation number of oxygen. So let it be X. How many oxygens are there? 2 oxygens are there. Plus barium belongs to alkaline earth metal or second group where all elements possess +2. So equals to, what is the net charge on barium peroxide? BaO2. It's a neutral species. So 0 on the right hand side. So 2X equals to -2, X equals to -1. Already we studied in peroxide each oxygen possesses -1. Understood? The same way, let us find oxidation numbers of some more species. Find oxidation number of M in MO2. Where M is 1A element. Where M is 1A element. What's meant by 1A element? It belongs to 1A group. 1A group is first group. All first group elements always shows which value? +1. So O2 will totally bear -1. Right? So in MO2 on dissociation M plus and O2 power -1. What is O2 power -1 called as? It is called as superoxide. Either from the rules or by finding in this way, we can find the value. Okay, like let us find the oxidation state of each oxygen. 2X, because each oxygen is X, 2 oxygens are there. 2X equals to, what is the net charge on the species? Now this particular ion is having a charge. Take the charge on the right side. So X equals to -12. What's the point I had given in the rules? Oxygen in superoxide possess minus half. See, the same value we got. Oxygen in superoxides possess minus half. See here. Understood? So this is how we can find the oxidation number or oxidation states of different elements in their combined form. Okay, let us solve some more examples, because this is the primary information which is required in the calculation of equivalent mass of oxidizing agents and reducing agents. It is just a primary information. Still, there are so many special cases which we are going to study in oxidation reduction concept separately. Just for the sake of finding equivalent mass of oxidizing agents and reducing agents, I am giving you a primary information, right? See, let us find the oxidation numbers of some elements. Find oxidation number of nitrogen in first one, NH3. Yes, find that of nitrogen in ammonia. Find the oxidation number or oxidation state of nitrogen in ammonia. So, as we have to find that of nitrogen, let it be X. X plus, what's the common oxidation state of hydrogen? I had specified, I insisted that point to remember. Hydrogen usually shows which value? +1. Charge is very important here. For oxidation state or oxidation number, the charge or sign is very important. Understood? Means whether it is losing or gaining. If it is losing, that should be shown with a positive charge. If it is gaining, that should be shown with a negative charge. That's why sign notation is very important. Now, once again, what's the common oxidation state of hydrogen? As it has to lose electrons usually, the common oxidation state is +1. +1 into 3 such hydrogens are there, equals to, what is the net charge on this molecule? Is it a positive species? Any positive charge is there on the species? Any negative charge is on the species? Then there is no positive, no negative. Then the net charge is 0, which is to be taken on the right hand side. Right? Now, nitrogen is taken as X. Hydrogen's common oxidation state is +1. Sir, you specified in one point that hydrogen also shows -1 when it combines with active metals. There, the metal has to lose electron, hydrogen has to gain. But here, what is the element present? Nitrogen. It is the third most electronegative element. You know the meaning of electronegativity. Tendency to attract the shared pair. Can it lose electrons to hydrogen? Not at all. Now, X plus +1 for hydrogen into 3 equals to 0. X equals to -3. So, what is the oxidation number of nitrogen in ammonia? -3. This is how the questions will be asked usually. Okay. Next one. Find oxidation number of nitrogen in N2H4. It is called as hydrazine. What is this called as? Hydrazine. Find that of nitrogen. It's your turn. Will you? As we have to find that of nitrogen, take it as X. As 2 nitrogens are there, take 2X. 2 nitrogens are there, take 2X. Plus, what's the charge on hydrogen? What's the common oxidation state of hydrogen? +1. Into how many hydrogens are there? 4. Equals to, what is the net charge on the species? 0. So, 2x plus 4 equals to 0. 2x equal to -4. X equals to -2. So, oxidation number of nitrogen in hydrazine means each nitrogen possesses -2 oxidation number. Each nitrogen possesses -2. Understood? One more question. Find oxidation number of nitrogen in NH2OH, which is called as hydroxylamine. What is that called as? Hydroxylamine. So, find that of nitrogen. Yes. Now, you can easily find it out. Right? Let it be X plus, each hydrogen is +1 into 2 plus, oxygen is What is the common oxidation state? It is not a peroxide, right? Peroxide means after separating all other atoms, it should possess O2 power minus 2. It should be like O2 power minus 2. It's not at all a peroxide. Only one oxygen is there. Peroxide means two oxygens are required. So this is not a peroxide. Even for a superoxide also O2 power minus 1, two oxygens are required. I am repeating, for a peroxide or a superoxide, minimum two oxygens we need, right? But here how many are there? Only one oxygen. Means it is just a normal oxide. What is the oxidation number of oxygen in normal oxide? Yes, minus 2. Each oxygen always shows minus 2. Plus, it is one more hydrogen. Again plus 1. Equals to, what is the net charge on the species? No charge. It's a neutral species. Shall I repeat? Yes. As we have to find that of nitrogen, let it be X. Common oxidation state of hydrogen is plus 1. For each hydrogen plus 1 into 2. Is that clear? Oxygen, one single oxygen is there. No, single oxygen is there. So single oxygen means it is just an oxide form. In oxide form, each oxygen possesses minus 2. We discussed it already in the rules. So minus 2 for one oxygen. And again hydrogen is there. Usually common oxidation state of hydrogen is plus 1. So plus 1 for again for single hydrogen equals to net value on the species is 0 because it's a neutral molecule. Now find value of X. X plus 2 minus 2 plus 1 equals to 0. X equals to minus 1. So in this particular example, oxidation number of nitrogen is minus 1. Have you followed? Similarly, one more example. Oxidation number of nitrogen in N2. N2. Nitrogen, sir, it is the available form, native state of nitrogen, isn't it? In native state, we studied some rule. In free state or native state or elemental state, oxidation number is 0. Let us get that point. See, let it be X. Two nitrogens are there. 2X equals to, what's the charge? Total charge? 0. Then it's not a charged species, so 0. So X equals to 0 by 2. 0. So hence proved, no? In elemental state or free state or native state, oxidation number of these elements will be 0. Understood? Similarly, one more example. N2O, nitrous oxide, which is also called as nitrous oxide, which is also called as laughing gas. Yes, I know you people are going somewhere, right? Nitrous oxide, which is also called as laughing gas. In this also, find the oxidation number value of nitrogen. So as two nitrogens are there, take 2X, X for each nitrogen. And only one oxygen atom is there, right? So it's a simple oxide or a simple monoxide where each oxygen possesses which value? In oxide form, what's the oxidation number of oxygen? Minus 2. You should not forget these points. So minus 2. Already we discussed it in the rules. Equals to, what's the net charge? 0. It's not a charged species, it's a neutral species. So 2X equals to minus 2 on other side become plus 2. X equals to plus 1. As I said, oxidation number must be with a sign either plus or minus, except for 0 of course, right? X is equals to plus 1. This is how we can find out oxidation numbers in the given species. Using this, we can predict, means by using these oxidation numbers here and there, before one reaction, after reaction, using these oxidation numbers, we can predict whether it is acting as an oxidizing agent or a reducing agent, about which we are going to discuss in our next class. Okay.